Let us continue our discussion on the chapter of polynomials, and we will be now doing the last part of this chapter, which is algebraic identities. In this chapter, we are going to study a total of 8 different identities. However, in this class, we will cover only the first 4 identities. The remaining 4 identities we will do in the next class. So, what is an algebraic identity, first of all? An algebraic identity is an equation which is true for all possible values of its variables. So, this is an equation in 2 variables, x and y. So, if you look at the left hand side and the right hand side of the equal sign, the expressions have only 2 variables, x and y. And if you substitute any value on either side, on both the sides of the equation for the variables x and y, the equation will remain satisfied. For example, if we put x equal to 1 and y equal to 2 on the left side, and similarly, if wherever there is x, you put x equal to 1, and wherever there is y, put y equal to 2. So put the same values for the variables, the equation will remain satisfied. And this is what is called as an identity, an algebraic identity. So there are many different identities. So we will see the first 4 today here. The first one is x plus y the whole square, which is given as x square plus 2xy plus y square. Again, we have the variables x and y. It could have been a plus b the whole square means a square plus 2ab plus b square. It could have been any other variable, m plus n, whatever. Okay, so we are going to use the variables as x, y, z, and so on. So depending on whatever the variable is, you'll have the expression which will take the same form as it is here. Okay, so we have x plus y the whole square given by this expression. Then we have the second identity, which is x minus y the whole square. So it looks very similar. The right hand side looks very similar to the first identity, except that the middle term, which is 2xy, which was with a plus, this comes with a minus in this case. So it's x square minus 2xy plus y square. Then you have the third identity, which is x square minus y square, which is equal to x plus y into x minus y. And then the fourth identity is x plus a multiplied with x plus b is equal to x square plus a plus b times x plus a into b. Okay, so these are the 4 identities. Now, what is the purpose of these identities and how they can be useful for us? Identities can be used for two major purposes. One is to factorize other polynomials. If you have a bigger polynomial, we can use these identities to factorize those bigger polynomials and find the factors of the polynomials. We can also use these identities to perform certain computations. So if we are given some numbers to perform some calculations, we can use these identities to perform those calculations or computations in a much simpler way, as we will see with some of the examples that we will be doing in this section of the chapter. So let us do the first example for this expression, x plus 3 multiplied with x plus 3, and we'll try to simplify this and find the final expression for this product, x plus 3 into x plus 3. So x plus 3 into x plus 3, we can use 2 different identities from identities 1 to 4 here and get the same result. So let's do both the methods, both the identities, and see and verify that we get the same results. So the first identity we are going to use is using the fact that x plus 3 into x plus 3 is basically x plus, let me write that, x plus 3 multiplied with x plus 3 is equal to x plus 3 the whole square. So anything multiplied by itself is basically the square of that number. So if we have 4 into 4, it means 4 square. A into a is a square. So x plus 3 into x plus 3 is x plus 3 the whole square, which is basically looking similar to the identity number 1. It's x plus y the whole square. In place of y, we have 3. So we can use the expression or the identity 1 to simplify this. So x plus 3 the whole square is taking the form of x plus y the whole square, which is x square plus 2xy plus y square. So in place of y, we have 3. So it's x plus 3 the whole square is x square plus 2 into x. In place of y, we are going to put 3 plus y square is 3 square. So we will get x square plus 2 into x into 3. 2 into 3 is 6x plus 3 square is 9. Okay, so this reduces to, or this simplifies to, x square plus 6x plus 9. We can solve the same algebraic expression using identity number 4 as well. So let's do that. X plus 3 into x plus 3, and this is also looking similar to the form of identity number 4, where we have x plus a into x plus b, except that a and b are same in this case. So it's x plus 3 and x plus 3, so that means a is equal to 3 and b is also equal to 3. So we could use this expression for the right hand side for the identity number 4 and solve this. So this is of the form x plus a into x plus b, which is x square plus a plus b times x plus a into b. So we can have x plus 3 multiplied with x plus 3 as x square plus a plus b. A is 3, b is also 3, so it's 3 plus 3 times x plus a into b is 3 into 3. Let me write that clearly. So it will be a is 3 and b is also 3. So we have x square, 3 plus 3 is 6 times x plus 3 into 3 is 9, which is exactly the same answer we got with the previous identity as well. So when you are given some expression, we have to look at which identity it looks similar to, or with which identity it resembles, and based on that we have to apply that particular identity and perform the computation of that particular expression. Okay, so we have done in this particular case the expression resembled two different identities, so we use both of those identities to simplify it, and we verified that we get the same answers. Okay, so irrespective of which identity you use, the answer should be the same as long as the procedure has been done correctly. So let us do one more example. We have x minus 3 into x plus 5. So this takes the form of x plus a into x plus b, which is x square plus a plus b times x plus a into b. And what we notice is that if we compare the given polynomial or given expression with the identity, we see that a is equal to minus 3. So it's x plus a. So x plus minus 3, we have x minus 3, and the value of b is 5. So we just need to substitute these values of a and b on the right hand side of the algebraic identity, and we'll be able to solve this. So we can write our x plus x minus 3, that is x minus 3 into x plus 5 as x square plus a plus b. A is minus 3 and b is 5 plus 5, so it's minus 3 plus 5 times x plus a into b. A is again, I'll write it here, a is minus 3 into plus 5. So we just need to simplify this now. So we will get x square minus 3 plus 5 is plus 2. So it is plus 2 times x, and minus 3 into 5 is minus 15. So we'll get minus 15 here. So we have plus minus 3 into 5. Minus 3 into 5 is minus 15. Plus minus 15 is minus 15. So this expression evaluates to x square plus 2x minus 15. Let us now do one more example, one more problem from the exercise, from exercise 2.4. So let me write that. So I'll do some selected problems from the exercise because many of the problems are similar. So there is no point doing all the problems from the exercise. So I'll do some selected problems from the exercise. So one of the problems that I'm going to do with regards to the first 4 identities is question number 1, part number 4, okay, which is y square plus 3 over 2 multiplied with y square minus 3 over 2. So we need to simplify this by using one of the identities. Let's see which identity we can use and what this evaluates to. So again, this one resembles our x plus a into x plus b identity. So it has the form of x plus a into x plus b, which is x square plus a plus b times x plus a into b. The only difference now is this. In place of x, we have y square. So it's wherever there is x, we have y square, and where a is plus 3 by 2 and b is minus 3 by 2. So what we are given is x equal to y square. That means in place of x we have to put y square. A equals plus 3 over 2 and b equals minus 3 over 2. So we just have to substitute these numbers in our identity on the right hand side. So in place of a, x plus a, we have y squared plus 3 by 2. So that means x is x is the same as y squared, and plus a is plus 3 by 2. So a is 3 by 2, and x plus b, so x is again y square, and plus b is minus 3 by 2, so b is minus 3 by 2. So we will substitute these values in the right hand side of the identity, and we will see what we get. So that will be the final answer. So y square plus 3 over 2 into y square minus 3 over 2. So that will give us, in place of x we have y square. So here we need x square, but x is y square. So therefore we'll have to write y square the whole square. So x is basically y square. So we need x square. So we put y square the whole square plus a plus b. A is 3 over 2. So that's 3 over 2 plus b. So plus b is minus 3 over 2. So plus minus 3 over 2 times x plus a into b. Plus a into b, a is 3 over 2 into minus b is minus 3 over 2. So now we have y square. By the way, here we have to, in place of x, I made an error here. So this is x here, but our x is basically equal to y square. So in place of x, we have to put y square. I forgot to put that. I just wrote the general formula. So in place of x, we have to write here y square. Okay, so now we simplify this. Y square the whole square is y power 4. Now we have 3 by 2 plus minus 3 by 2 into y square. So it's plus 3 over 2 plus minus 3 by 2 is minus 3 over 2 times y square. And now we have this product plus 3 into minus 3 and plus 2 into 2, right? So 3 by 2 into minus 3 by 2 will become minus 9 by 4. So we'll have it as minus 9 by 4. Okay, so now the middle term is 3 by 2 minus 3 by 2, which is 0. So therefore we will be left only with the y power 4 minus 9 over 4. Okay, that's the final answer for this, because we have a equals 3 by 2 and b is minus 3 by 2. So when you add a plus b, we will get 0. So this evaluates to y power 4 minus 9 over 4. Okay, we have seen quite a few examples now, and it is fairly clear how to use the algebraic identities to simplify the algebraic expressions. Now let us see one of the utility or uses of the algebraic identities in performing calculations or computations. So let's take a simple example here. So So we want to evaluate some calculation. So we want to evaluate. So let's say we want to multiply 105 with 106, and we want to do this without actually multiplying these numbers. We will use one of the algebraic identities to perform this calculation without actually having to multiply these two numbers. So what we can do is we need to represent these numbers or this calculation in terms of one of the algebraic identities. So what we can do is we can write the 105 105 as 100 plus 5, okay, and similarly we can write the 106 as 100 plus 6. So now we can write 105 into 106 as 100 plus 5 into 100 plus 6. Now this is taking the form of x plus a into x plus b. So this looks similar to the identity. This is similar to x plus a into x plus b, where our x is having the value of 100 and a is 5. So x is again 100 here and b is 6. So the expression for this is x square plus a plus b times x plus a into b. So we can use this identity and solve this. So we can write 105 into 106 equals 100 plus 5 into 100 plus 6, which is equal to x square is 100 square, so we can write 100 square plus a plus b times x. So what is a plus a in this case is 5 and b is 6. So 5 plus 6 times x is 100 plus a into b is 5 into 6. So 100 square is 100 and 100, so it's 10,000. 5 plus 6 is 11, so plus 11 into 100 is 1100, plus 5 into 6 is 30. So we just need to add these numbers. So we'll have 10,000, 11,130, right? So we get 11,130 if we add these three numbers, okay? So it's 11130. So we have seen here how we can use the algebraic identities in performing some calculations, okay? So when you're given some numbers like this, we can represent those numbers in terms of the in a style which is similar to one of the algebraic identities, and then use the identity to perform the calculation. So we have evaluated this product without actually multiplying these two numbers. So we have used much simpler numbers to do the calculation. It's easier to find 100 square or to multiply some sum with 100 and then add them together rather than to having to multiply these two numbers directly, okay? So algebraic identities are used for computing certain calculations as well. So this is one of the uses of the algebraic identities. Let us now do one more example of evaluating some products from the exercise part. So we'll do question number 2, part 1. So I'll do only one of the exercise problems. So it's again exercise 2.4, and we are going to do question number 2 and the first part of question number 2, where we have to evaluate (103) into 107. Okay, so how can we use an algebraic identity to evaluate this? So we can write 103 into 107 as 100 plus 3 into 100 plus 7. So again, this is now of the form x plus a into x plus b. So x plus a into x plus b, which is x squared plus a plus b times x plus A into B. So in this case, our X is equal to 100, A is equal to 3, and B is equal to 7. Okay, so we have, let me write those as well. X equals 100, A equals 3, and B equals 7. So we can now substitute these values on the right hand side of the identity and get the answer that we need. So in place of X we have 100, in place of A it's 3, and B is 7. So we can write now 103 into 107 as X square, which is 100 square, plus A plus B times X. So A is 3 and B is 7 times X is 100, plus A into B, 3 into 7, so that's 3 into 7. So 100 square we know is 10,000. 3 plus 7 is 10 into 100, plus 3 into 7, oh, that's plus 3 into 7 is 21. So we have 10,000. 10 into 100 is 1,000 plus 21. So we have 11,021. It's 11021. Okay, so we have 10,000 plus 1,000 is 11,000 plus 21 is 11,021. You see, we have been able to compute this product by using the algebraic identity in a much simpler way, rather than having to directly multiply these two numbers. Okay, so this is one of the utility of algebraic identities. Now let us do one more example of a use of algebraic identities. As I said earlier, one of the uses of the identities is in factorization of polynomials. So let us see some examples now of how to use algebraic identities to factorize polynomials. Okay, so let's see how we can use the identities to factorize some polynomial. So here we are given a polynomial in two variables, a and b. So we have 49a square plus 70ab plus 25b square, and we need to factorize this. So let's see with which identity this is similar to. So let's write 49a square plus 70ab plus 25b square. So first of all, the 49a square, we can write it as 7a the whole square, right? So 7a the whole square, 7 square is 49, a square is a square, so 7a the whole square. So we can write 49a square as 7a the whole square. Similarly, the last term, which is 25b square, we can write it as plus 5b the whole square. So if I have 5b squared, it gives us 25b square, which is what we have here. So the middle term now can be written in terms of these two terms which we have. So it's like x square plus y square, and we can have like a plus 2xy. So this is like the x here. X is 7a. So we can write 7a in place of x, 7a. And let me leave some space here. 7a. And 5b is the y. So that's 5b. And we'll have a 2. So plus 2. So this takes the form x square plus 2xy plus y squared. So now check whether this evaluates to 70ab. So 7a into 5b, 7 into 5 is 35, a into b is ab, so 35ab into 2 is 70ab. So we get back this, right? So we have 49a square as 7a the whole square, and 70ab we have it as 2 into 7a into 5b, and this is the y square, which is 5b the whole square. So basically the 7a is denoting the x, the 7a again is x, the 5b is y, and the 5b here also is y. So we are having this expression. This is of the form. This is of the form x square plus 2xy. So we have this as x, this is y, and then there is a 2 here. So we have this as x square plus 2xy plus y squared. And this is nothing but, we know the identity x plus y the whole square. So x plus y the whole square is x square plus 2xy plus y squared. This is our first identity number 1. And this expression resembles identity number 1. So in place of x we have 7a, and in place of y we have 5b, and then we have x square plus 2xy plus y square. So therefore we can write our 49a square plus 70ab plus 25b square, which is 7a the whole square plus 2 into 7a into 5b plus 5b the whole square as x plus y the whole square. In this case, x is 7a and y is 5b. So we have 7a plus 5b the whole square, which is 7a plus 5b into 7a plus 5b. So anything squared means multiplying the same number with itself. So 7a plus 5b the whole square is 7a plus 5b into 7a plus 5b. So we have factorized this expression into its factors. So the factors are 7a plus 5b and 7a plus 5b. Okay, so we have seen how we can use the identities to factorize some algebraic expressions. So but you have to be very clear how to rewrite the given expression in a form that resembles one of the identities. So you have to do that very carefully without making any errors. So you'll have to look at the patterns within the expression and identify with which particular identity the expression resembles. So just to be clear, let's do some more examples. Okay, so I'll do one problem from the exercise, question number 3, part number 1 from exercise 2.4. So again we have an expression here which we need to factorize. So let me write here, factorize. So now we can write this expression 9x squared plus 6xy plus y squared. So 9x squared we can write it as 3x the whole square, and y square is going to be as y square, and here we are going to have 2xy, so 2 times 3x, so whatever is the first term, that will be 2 multiplied with the first term multiplied with the second term, which is y, plus the third term, which is y squared. Okay, so now we have this in the form 3x the whole square plus 2 into 3x into y, which is 2 into 3x is 6x into y is 6xy plus y squared. Okay, so now this is of the form x plus y the whole square. So this is of the form x plus y the whole square, which is x square plus 2xy plus y square. The only difference now is in place of x we have 3x. So basically in place of x we have 3x, and in place of y we have y itself. So this is going to take the form, so therefore we will write 9x squared plus 6xy plus y squared, which is rewritten in the form 3x the whole square plus 2 into 3x into y plus y squared. So in place of x we have 3x, and in place of y we have y itself. So we can write this as 3x plus y the whole square, which is basically in terms of the factors we can write it as 3x plus y into 3x plus y. Okay, so we have seen we have used the identity again to factorize the polynomial. Okay, let's now do one more sum from the exercise where we will be using a different identity. In the previous two examples, we have used the identity x plus y the whole square, right? Let's see some more examples of factorization where a different identity would be used. So in this case, we have x square minus y square divided by 100. So how can we rewrite this? We can write this as x square minus y square by 100 can be written as x square minus we can write this as y by 10 the whole square, right? So y over 10 the whole square is y square divided by 100. So when we square y, we'll get y squared, and when we square 10, we'll get 100. So this will still be the same as the left hand side. Now this looks this takes the form of, so let me rewrite that by x square minus y over 10 the whole square. Okay, so now we have this in the form x square minus y square. So we say that this is of the form a square minus b square, which is equal to a plus b into a minus b, which is taking the form of the identity number 3. It's x square minus y square is x plus y into x minus y. So instead of x and y, I have written it as a square minus b square. It is a plus b into a minus b, which is what has been it has been represented as. So a square minus b square is a plus b into a minus b. So this is in place of a we have x, and in place of b we have y over 10. So a equals x and b equals y over 10. So we can write our expression x square minus y square by 100 to be equal to x square minus y over 10 the whole square, and that we can write as in the form of a plus b into a minus b. So this is x plus y over 10 into x minus y over 10. So we have now got the factors of this particular expression, which are x plus y upon 10 and x minus y upon 10. So the product of these two gives us this particular expression, x square minus y square by 100. Okay, so that's one more example. Let's do another one which uses a different identity as well. So I'm going to do question number 3 part 2 as well. Okay, question number 3 part 2. The question is, so we have this polynomial for 4y square minus 4y plus 1, and let's see with which identity it resembles. So how can we rewrite this expression? So we can write 4y square as 2y the whole square, so that is still 4y square, and minus, we can write it as minus 2 into x into y plus y square. That's 1 is simply 1 square. So in place of 2ab or 2xy, we can have 1 here. So what is the remaining term here? 2 into what into 1 will give us minus 4y. So it will be the same term which is here, okay, the first term. So x square minus 2xy plus y square. So y is 1, we have put that 1 here, and x is 2y, so we'll put that 2y here. So now we have 2y the whole square, which is 4y square, Minus 2 into 2y is minus 4y, into 1 is minus 4y, plus 1 is 1 squared. Now if you look at this resembles the identity. So this is of the form x minus y the whole square, which is x squared minus 2xy plus y squared. So in place of x we have 2y, and in place of y we have in place of this y we have the 1. Okay, or we can say we can write this as so therefore, so wherever there is an x we have a 2y, and wherever there is a y we have a 1. Okay, if you compare this expression, with this particular expression, you see that in place of x we have 2y, and in place of y we have 1. Okay, so x is 2y. So we can write our expression 4y squared minus 4y plus 1 as 2y the whole square minus 2 into 2y into 1 plus 1 square. So this is of the form 2y minus 1 the whole square. So it's a minus b the whole square, or x minus y the whole square. In place of x we have 2y, and in place of y we have 1. So it is 2y minus 1 the whole square. So we have obtained our factors. So since it's whole squared, we can write it as 2y minus 1. So 2y minus 1 into 2y minus 1. Okay, so this is the factor. So in this case we have used the identity number 2, which is x minus y the whole square. This is using identity number 3, which is x squared minus y squared is x plus y into x minus y, right? Or a plus b into a minus b. Okay, whatever is the variable. So the trick here is to identify, or to look at the given expression and identify how this expression can be rewritten in a form that matches one of the identities that we know of, and then use that identity to simplify it further. Okay, so you have to do it very carefully, and it will require a bit of practice to become confident in solving these problems using these identities. So it is important that you practice a lot of these problems and solve all the questions given in the exercise. I have solved a few of them in the video, but you should make an effort to solve all the problems in the exercise and practice them, so that it will help you identify the patterns by looking at the expression and find the similarity with which particular identity the given expression resembles. Okay, we'll stop here for now, and I will continue in the next video, where I will talk about the remaining 4 identities. As I said, in this chapter you have a total of 8 identities. So far we have seen 3 identities, and we have seen 4 identities, and all the 4 identities that we have seen, they have the highest power as 2. The degree of those polynomials is 2. We will see one more identity with the degree 2, and then we will also see some identities, 3 identities whose degree will be 3. So we'll have something like x plus y the whole cube rather than the whole square. Okay, so we'll talk about all those things in the next class, and we will also do some more examples using all the identities. And basically, to summarize, identities are used for 2 main purposes. One is to factorize algebraic expressions, and the second is to perform certain calculations. Okay, like we saw how to multiply 105 with 106 and so on, right? So we can use the identities and perform the calculations in a much more efficient way. Okay, I'll stop here for now, and we will continue with our discussion of the remaining topics in the next video.